Danny and ZK Marketer talk Mina nodes. So maybe we can start with talking about the differences between the Rust node and the Mina web node.
The web node is a component of the Rust node. And what's exactly the Rust node initially? The Rust node is a new implementation of the Mina protocol. So the first implementation of Mina was in OCaml. So what's the difference with the web node? The goal of Mina since day one is to have everyone, even if you're not technical, to just be able to run a node and verify blocks and verify and participate into the consensus, create blocks, etc. And how can we achieve this is by as everyone, even our grandmas or even everyone in the using web, use a web browser when we go on the internet. And the idea is to have what we call a web node, which is running the Mina protocol in the browser. So the Rust node, if you go on OCaml Mina Rust, it's a Rust code base, but thanks to the stack that the Rust community built, we can also compile the Rust code into JavaScript or WebAssembly in our case, so we can run it in the web browser. And that's exactly what we call the web node, running in the browser. So that's exactly the same code base, exactly the same.
Yeah, maybe next we can dive a little bit deeper into the Rust node, and also maybe for people watching, explain, what is a client and, why are they important? Why is client diversity important?
What's exactly a client? A client it's a software that can be used to participate into the protocol. More people run the node, the better the network is, because we need a network that is resilient. So that's also one reason that we want to have a web node, because it makes the network more resilient and more secure, because anyone can just run a node. It's not only for people with DevOps skills. And why the client diversity is important? So as I said, is for the network resiliency. We need to be sure that the network is secure, and we want to have multiple clients because, as in every software, the OCaml node can have bugs. There can be exploits also in it, and with more different clients, different implementations mean that we test more cases. Which is also very important is that if you got different clients, the engineers who want to work on Mina, they do not have to work on only one code base. So if you are not an OCaml engineer, for instance, at the moment, you cannot contribute to Mina. So therefore, having different implementation, in particular Rust, allows more people to contribute to the project. And by the way, we saw that when we started posting on Twitter, people were excited by just contributing. So I got a few DMs. You can check the issues, by the way.
Perfect. Thanks, Danny. Diversity is really important across the industry, and we've seen sort of Ethereum really leading the way there with multiple clients. But maybe we can talk about the current Mina OCaml node. Maybe we can talk about why it was chosen at the time, the benefits.
Why OCaml is because, as other projects like Tezos in particular, you have in the OCaml community the idea of being able to formally verify the code, or having the benefits of the whole type system. You can encode many invariants into the type itself, and you can check, by the way, the code, for instance, pickles. Most of the invariants are encoded at the type level. So it makes the code a bit more complicated, but you can be sure that when you compile the code, you're gonna avoid many bugs that could happen at runtime. So you can encode the number, for instance, on the peer-to-peer layer, we encode the type of messages that we receive on the network, and so it's detected automatically if, for instance, we send 10 bytes instead of 11. That's an example. I really like OCaml because it's really simple, in my opinion, but it's not shared by everyone. And also another reason for the OCaml node initially was to have something that we call now O1JS, so being able to do some client-side proving. OCaml is the only one that I know of back then that were provided an easy way to compile OCaml to JavaScript, and therefore running the same OCaml, the same code than the node runs, but in the browser. So back then also there were no OCaml, there was no this Rust community around cryptography. I think it happened like 2019, 2020.
Thanks for clarifying that, Danny. So we now have the Mina node, which is written in OCaml, the Rust node, which is being worked on, and then also the Mina web node. Perhaps we can talk about the Mina web node specifically and like what that unlocks. Why is it unique to Mina?
So what the web node is going to allow us is to have anyone participating to the Mina protocol by simply opening a web browser. You just click on a button and bam, you participate to the protocol. So why is it unique to Mina? Running a node on mobile has been the hype for like the last 10 years. I mean, Ethereum also wants that. Thanks to the particularities of Mina, which is you do not have to download the whole chain. You just download the proof and you can verify it, and you can start synchronizing the chain based on this initial proof. You don't need the whole history, so you can just have an archive node running somewhere, and you can just query it if you need. But like to just participate to the consensus, verifying that the consensus works and the participants follow the consensus, for Mina it's very lightweight. So you could just open the browser on mobile and you can participate to the consensus. You won't be able maybe to produce blocks initially. We still gonna have to go there. So you're gonna have like a button, produce blocks, and you just add your keys and you can get rewards by simply running a browser. That's crazy. No, you can just get rewards. You just start your day, you just open the browser instead of having YouTube taking 2 gigs of RAM or 3 gigs of RAM and having Chrome crashing every 5 minutes. You can just have a tab opened and it's going to reward you because you participate to the security of a network and produce blocks. We're not there yet. We've got to investigate some technicals like the memory that is required to verify to produce a block, because WebAssembly is restricted to 4 gigs. I saw some people on Twitter asking me why we do not focus on mobile first. That's a very good question, by the way. The reason is by having an implementation in Rust, we can create mobile application based on the Rust code because Rust can be run on mobile too. We have to compile it with a different backend. I posted also like some months ago a tweet that if someone wants to work on it, please just ping me because I wanna help on this. Other projects like Zcash does it pretty well with Zashi, for instance. They also re-implemented in Rust the initial C++ implementation of Zcash. They reuse some code of the Rust node in the Zashi mobile application. By the way, good work for the team. So I really like it. I really enjoyed reading the code.
Quickly share with people where they can follow for updates.
You can follow me on X, dwillems42, and I'm trying to post at the end of the week. I try to post the updates of the last week. There is a dashboard with the different epic that we're working on. You're gonna see the PR. You're gonna see the different issues. You're gonna see where we are going. Everything is transparent. So I'm leading the team, and that's one of our aim in the team is to do everything in open. So all the issues, everything we're working on are on GitHub, and you can follow all of our work there.